the Node MCU, which acts as a bridge between the user and the application. Next is the motor on the top of the page. Motor driver. We can connect up to two motors at the same time. There are two outputs given here. And depending on the input we are giving, it rotates in a clockwise and anti-clockwise direction. Ma'am. Next is down. We can see the temperature sensor working here. On the right side is the soil moisture sensor which is used, ma'am. Next, we have implemented this using the Blink app, using three gauges and the two buttons, ma'am. If the level gets indicated to the user using it through his mobile application, soil moisture and temperature and humidity are provided through using these gauges. Next, the soil moisture and the temperature and humidity sensor are bridged micro from the Node MCU. Our jumper waves we had done using that, ma'am, and breadboard using connections. The soil moisture sensor senses the calibrates dampness of the soil and send actuators by using Wi-Fi. Depending on the threshold, functionality is monitored, ma'am. Power supply is given by a 9-volt battery. Notification is given through the Blink app, ma'am. Next up, if we see the coding part of the implementation, I will show you. Sorry, not this one. Ma'am, is it visible, ma'am, my coding part and implementation part?
Yes. Now it is present.
Yes, ma'am. Yes, ma'am. We are using a lot of libraries we are using Blink app so that we are for integrating Blink and this Wi-Fi. We have used this Blink Simple ESP8266.h library, ma'am. The simple timer is the timer. Timer used to for maintaining. For we are using a lot of libraries we are using Blink app so that we are for integrating Blink and this Wi-Fi. We have used this. Echoing. Ma'am, next up is we are using a Delos temperature, which is a temperature sensor. Used to integrate the temperature sensor. Next up, if we go first, the things are read by this is. The authentication code is provided here, and my Wi-Fi details have been given so that it gets connected. First, it reads the temperature and humidity and sends if failed to the read the DAC sensor. If it is not read correctly, the Blink app writes it. Displays the temperature using the gauge node. Gauge in that. Next up, according to the threshold given in here, it allows to turn on the motor so that water gets watered, ma'am. This is how the plant gets watered. That's it, ma'am.
What will be a future scope, Tarun Vijay?
Actually, we are planning to use a cloud, integrate cloud to it, because when water is being when the plants are watered, it can be maintained and recorded in the cloud, ma'am, and it will be very useful for the customer during times.
Okay. Is implementing in the hardware, is it easy? As what's your knowledge onto it?
Yes, ma'am. It is kind of easy, but if you give the connections wrong, even the application may stop working. The connection part is kind of tough, ma'am. Working on it, ma'am. I'm learning on it to develop perfectly in the future.
Okay. Tarun Vijay and Balachandar, proceed.
Thank you.
You can join in the live stream, okay?
Yes, ma'am.
Yeah, okay, ma'am.
Yes, ma'am.
Next team.
Good afternoon, ma'am. My project is IoT prison break alarm and monitoring system. So I'm going to present the Is it visible, ma'am?
Is it about to start? Yes.
Yes, ma'am. I'm doing this project with Yashwant Kumar. The project title is Prison Break Monitoring and Alerting System. Generally, prison break means an illegal act of inmate leaving the prison through official, unofficial, or illegal means. Generally, when this happened, the physical part of authorities will try to recapture them, ma'am. But in this project, we are going to use IoT technology to prevent that. At present, now the existing system in prisons has surveillance camera and security guards, ma'am, to monitor the prisoners near the perimeter wall and near the gate of the inmate cell. This approach was easily watched by the prisoners to deviate the officials and security to escape from the prison. To control these undesirable situations, we are going to implement the few IoT technologies, ma'am, like using perimeter wall fencing and RFID tag. In this project, we are going to work on a variable non-detachable component which has GPS and microcontroller, and also we will use RFID tag implemented in the prisoner ma'am, so that we can trace whether when he passes any gate or any portion of the prison, like he is in section 1 or he is in section 2, like that. Using this RFID tag, we can trace when he entered to a new section of the prison. Using the GPS component, if he escapes, we can trace the location of him. The main challenges in this project is we need hardware components, ma'am, and also the battery life to control the battery life, ma'am. Here, the device will be working only when it's in motion, ma'am. Like prisoners, while they are moving only, it will work, ma'am. When they are in rest, it won't work and it will save the battery. We are trying to use kinetic movement for charging. Reason behind this proposed feature, according to a news article which was published in 2015, two prisoners have been escaped from maximum security prison which is in India, Tihar jail, by digging a tunnel under a wall and scaling to another place. Authorities said like this, 500 prison breaks will be reported for every month generally. This is the report chart of a number of escapes reported in 2017 according to NCRP. For our project, this is the block diagram. We are going to use the GPS satellite and location tracer. We are going to implement it in non-detachable chip component with RFID tag and GPS. When he tries to escape, when he is near the fencing of the prison, we will get a notification. We will get an alarm. Also, we will get the SMS status of prisoner. The modules we require is RFID tracker, GRPS component, microcontroller, and Wi-Fi communication module, and alarm and GSM module. This is the circuit diagram. Ma'am, we will get a notification like this, ma'am, if we implemented this. Actually, we require the hardware components of RFID tag and many of geolocation chips, ma'am. It is not available currently in Tinker card. So, without using this, we propose a basic limiting prevention system of prison break monitoring. I will show you that in next. This is the conclusion. Ma'am, this is the basic implementation without using RFID tags and location components in Thinker pattern. Using this, we can capture the prisoner. If there is any prisoner movement near the fencing, we will get a status like this. Prisoner is moving. We will get an alarm buzzing, ma'am, and we will also get the display message also. Prisoner is moving. This area is near this security fencing, ma'am, outside the prison. If he is not near that, it won't show even prisoner is moving. Only near the security area of escaping, it will show when there is a movement near here. In future, the future work is going to be using the hardware components of RFID tag and Wi-Fi module and GSM microcontroller and location circuits. With that, we are going to implement in future. After developing the future physical component, we are going to connect it with IoT Gecko using the same Wi-Fi module. We will get whenever a prisoner is disconnected with RFID tag or whenever he escapes from the prisoner. After connecting with physical circuit. Actually. Like this one. Whenever a prisoner escapes, we will get a buzzing alarm and status which prisoner has been escaped from the jail. That's it.
Nikhil, what tool, what website you used to display the sound?
IoT Gecko, ma'am.
It's a free versions, free trial versions available?
Yeah, yes, ma'am, available.
Okay, what are the functionalities they are providing, extra functionalities they are providing?
Actually, they are providing the basic model of this prisoner monitoring system. They are providing inbuilt, ma'am. After connecting the physical device, we can change and add specifications, ma'am. Currently, it's not possible.
Okay.
Yeah.
Okay, fine. Good. Next team.
Good afternoon. Myself, Patrick. I'm one of the president. Is it visible now?
Not yet, Anirudh.
Hello?
Yes, it is about to start.
No, no. Is it visible now?
Yes.
Okay, ma'am. Our title is Accident Alert System. In this, you will get an alarm or buzzer when an accident is about to happen. Like if two vehicles get closer, then it will give you a buzzer. Here we have divided into 3 zones. Like the distance between the vehicles are set into 3 zones. In zone 1, it's a no warning zone. It's a safe distance. There will be no buzzer, no warning. And in zone 2, the driver needs to pay attention here as it is visible in this picture. When this car, when this yellow car gets near to blue car, you will get only the LED visual light. You need to pay attention. And then in zone 3, when the vehicles are too close, it will the LED will blow up and both the alarm will ring loudly. Uh, these are the three segments. In this, we have used ultrasonic sensor, accelerometer, and position sensor. Uh, our future work is like when we want to develop thing like if there is an accident prone area in the path you are traveling, the system will notify you via GPS or an SMS thing. So you if you are 100 meters away from the accident prone area, it will alert you like in 100 meters there is an accident prone area. Drive carefully, and and if someone is doing a rash driving and signal jump or some drunk and drive case, the traffic police will display the messages in the hoardings like a digital screen hoardings. Whoever the people driving in those area can check for it and go safely. Now, Anush will show you the demo.
Ma'am, is my screen visible, ma'am? Hello? Ma'am, is it visible, ma'am? Ma'am, we have done this in Tinkercad, ma'am. Now I'm starting simulation. Ma'am, this is the safe zone, ma'am. Here. So at the safe zone, the green LED will be blinking, ma'am. This is safe zone. This, this is second zone, ma'am. Here the yellow light will be blinking. In the third zone, the red LED and the buzzer will be buzzing, ma'am. And it is closed. Vehicle. That's it, ma'am. Yes, ma'am. Ma'am, here in ultrasonic sensor, we calculate the distance, ma'am, between 60. If the distance is greater than 60, is safe zone, ma'am. If it is below if it is between 60 and 20, it is in the second zone, ma'am, warning zone. If it is less than 20, it is a danger zone, ma'am. Yes, ma'am. We are trying to implement if we are heading towards the accident prone area, it will notify before, ma'am. We are trying to implement that, ma'am. Ma'am? Yes, ma'am. In software, we do not have the GSM module, ma'am. In Tinkercad, it is not available, ma'am. Okay.
Thank you.
Conversation and understanding. Hello, ma'am. Hello, ma'am. Ramesh, Ashwin, and Anisha. I shall share this. Ma'am, our project is about smart bills reals. Ma'am, it is a app where it gives the information to the healthcare providers when the person is taking a pill. It will analyze for when a pill is taken out of the container, the corresponding data is synced with the app, and alert is sent to the officials or the trusted contacts of the user, so that it will check whether the bill is taken correctly or not, or it will alert when the bill is taken overdosage, and that's now Anisha.
Good afternoon, ma'am. As Tanush Ashwin said, we have developed a smart pills box. What it basically does is it sends notifications when a pill is dispensed. The motivation of the project is like many medical errors are due to the fact that people in charge of patient or elders medication have to deal with sorting huge amount of pills each day. So this will lead to either overdose or microdose, either intentional or unintentional. So to overcome this problem, we have developed this smart pills box. Ma'am, can you see my screen? Yeah. So the abstract is the smart pill bottles actually help address the antidepressants and antipsychotics epidemic. Um, the actual functioning of the smart pill box is that when a pill is taken out of the container, the corresponding data is synced with the app. If more than the prescribed dosage is dispensed, an alert is sent to the officials or the trusted contacts that the user chooses from the sync data on the application. So this prevents drug overdose, drug abuse, and thus preventing suicide. So this is the existing system. The existing systems just have the hardware component with the blink lights to notify the users. But the proposed system will have the software as well, the synced application. Uh, the advantage of the proposed system over the existing system is that we can achieve a high degree of scalability and a high degree of remote manageability since it incorporates a software or an application and thus promoting remote management. So this is the block diagram. We used the node MCR. We didn't really use it, but then the future scope of the project is the hardware component. So it contains an Arduino board, 32-bit node MCU Wi-Fi module, and OLED display, a buzzer, and a reset button, and the basic components, the LEDs. The mobile application will be integrated to the cloud, so that the data will be synced with the cloud. So that's the block diagram. These are the system modules. There are three modules: pill dispensing module, pill refilling module, and notification module. So the mechanism for the pill dispensing module will be the usage of two Arduino controlled servos. One of them located under the LED and attached to the pill storage cylinder. Once the pill release stage is completed, the system will reset itself to the default stage. It basically goes through three stages. The first stage is the pill storage. The second stage is the pill hatch. The third part is the pill chamber, and the fourth part is pill pipe. So that's about the dispensing module. It basically dispenses the pills as per the timing in accordance with the prescription. Pill refilling module, as the name suggests, it's to refill the pill box with a minimal chance for errors in the process. The notification module is the one that sends the notifications once the pills are dispensed. And even if the pills aren't dispensed, we'll be getting notifications accordingly. This shall be achieved by push bullet of Node-RED or the push bullet function of Node-RED using access token and the corresponding username. Uh, this is the design we did on Node-RED. So one second. Uh, in case we forget to in case we forget to to take a pill, we'll be getting the notification as pop a pill here. Say we took the pill in the correct time, we will be getting the message as good to go. And if you take more pills, we'll be getting the message as an OD alert. So that's the notification module. This one is the notification module. This one is the I forgot module, which basically tells you if you forget to take a pill, it gives you the information of the pill and the message. For example, say you forgot your risperidone, which is basically an antipsychotic, and if you forget to take it, you'll be getting a message as please take that pill along with your diagnosis. If you're diagnosed with three disorders, you'll be getting the name of each. For example, BD, which is bipolar disorder, BPD, borderline personality disorder, and stuff like that. So personally, I've been using this Pilsy smart pills. The disadvantage of the pill is that pill box is that we have to fill the pills manually. Filling the pills manually will dampen the pills and may as well contaminate the pills. In our proposed system, we'll be actually using the manual method, but then the future scope will be making it automatic. For example, we have been thinking about implementing stepper motor to dispense the pills at the correct time in accordance with the prescription. So that's about it. And this basically overcomes the problems of existing medication dispensers, as said before. This prevents overdosing, microdosing, and underdosing. It also diminishes the proportion that patient misses and defers taking medication. So this finds use in the healthcare domain and thus saving lives and making lives easier. So that's all, ma'am. This one, ma'am. If you have an app integrated, we'll be getting the notification on the application. But then I'm using an iOS, so the push bullet they have stopped their application on the iOS platform. Like we have to make it cross-platform using some other functions. It's now only available for Android and Windows. No, ma'am, I didn't do it. We only designed the pill on the Tinkercad application. Like we just designed the pill box. Yes, ma'am. Yes, ma'am. Basically, this pill box will be containing 9 sub boxes. Like, for example, if a patient is mentally ill, he or she will be prescribed a maximum of 9 pills. So, in general, like in most of the cases, so we'll be having 9 sub boxes on the pill box. We could have made an UI interface, but then we didn't do it actually. He designed the pillbox on Tinkercad, ma'am. I mean, this is the basic outline of the pillbox. Like, it looks very normal. It will be connected to the. I mean, it will be connected to the Wi-Fi module, Node MCU. Yes, ma'am.
Where, ma'am? Hello, ma'am. Ma'am, I work on the Tinkercad and helped with the implementation. It's all pasted in the PPT. It is done in the PPT itself. I showed you. Yes, ma'am. Actually, I didn't team with Anisha only. I didn't do in my system. Kamush Ashwin. Yes, ma'am. I designed the pillbox, ma'am. Yes, ma'am. Yes, ma'am. Can you repeat it, ma'am? Yes, ma'am. Ma'am, when bill is not taken correctly, then it pushes the notification to function mode. That's how function mode works. There are three functions, ma'am. Pop-up bill, one is Bodos alert and ma'am, it's engine function, ma'am. Inject mode, ma'am. Hello, ma'am. Ma'am, pop, that pop bills, pop notify, that three are the inject modes. Yes, ma'am. Yes, ma'am. Ma'am, is it visible, ma'am?
Ma'am, can you still see my screen?
Yes, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Good afternoon, ma'am. Ma'am, this is Kaushik, ma'am. Okay, ma'am. Ma'am, can you see my screen, ma'am? Hello, ma'am. Ma'am, can you see my PPT, ma'am? Okay, ma'am. Ma'am, this is my part is on social distancing analyzer, ma'am. So, firstly, the problem statement, ma'am. Nowadays, we have entire world is facing the COVID, ma'am. So, to get rid of the COVID virus, the main uh, the main thing is we should keep ourselves safe. To keep ourselves safe, there are some certain measures, ma'am, like wearing mask, taking sanitizer, and mainly being social distancing in some areas where we can see people, ma'am. So this is my problem statement, ma'am. When it comes to introduction, ma'am, the same nowadays we are saying about COVID, ma'am. So to record a video, I'm using OpenCV and yellow models, ma'am. These two are used to record the video, ma'am. About OpenCV, ma'am. I have taken OpenCV because it will capture the image and it will show it as real-time computer vision, ma'am. So it is used to provide a common infrastructure, ma'am, to computer vision algorithms, ma'am. Next, coming to LOV, ma'am. In LOV, I have taken LOV3 version, ma'am, which is the latest version, which is better and stronger, ma'am. Sorry. It has fast and accurate algorithm, ma'am. It makes detection of algorithm with three different stages, ma'am. Like the dam detection cannot. Uh, when you take a video, it will retrieve the image in that video with in three different sizes and three different places, ma'am. So I have chosen LOV3 version, ma'am, which is latest one. Coming to my abstract. Uh, My abstract is to calculate the social distancing among people in random areas, like by using our mobile phone or CC cameras or any footage which we should take as our data set, ma'am. So this is my block diagram, ma'am. So first, we should get our camera file. So we have to record the people around, like we should record the people. So the system will localize the position. It will take it to frame. Then it will connect into a board side view, like it will make it a single frame. From there, it will calculate the distance between among people, ma'am. After that, it will show the lines among the people, ma'am, like whether they are in proper social distancing or they are not following social distancing. It will show that, ma'am. Finally, it will show the message to us, ma'am, like they are in social distance or not, ma'am. So it is the working of my product, ma'am. So I have using yellow for object detection, ma'am. Once people are detected, it will draw boundary boxes around them, ma'am. Using centroid box to measure the distance between them. Then for finding distance, I have used Euclidean distance, ma'am. So if a person is shown in the red color box, it shows he is unsafe and he is in the danger zone. If a person is shown in green box, it shows he is safe. Then we also count the number of people are in safe and red zone and unsafe, ma'am, and we give message to us, ma'am. So this is my partial, this is my output, ma'am. Like I'll show the demo after now, ma'am. This is my output. We get like this, ma'am. Demo, ma'am. So here you can see, ma'am, a group of people sitting there. So they are it shows that they are safe, and here you can get the count as a total count of 4. Safe count is 4. If there is any risk possibility, it will show it as 2, ma'am. And if there is any high risk quantity like that, then the red zone, it will show it as 0, ma'am. These are the demonstration of the lines, ma'am, like which are showing. Yellow is very close, red is very close, and when it comes to boundary values, dark red high risk, green safe, orange low risk, ma'am. And ma'am,
Yes. What is the tool you used it here?
is it, ma'am?
What is the tool you used it here
Uncounted
for?
account, ma'am. I have taken uncounted account to run my code, ma'am.
Can you explain your code?
Yes, ma'am. Yes, ma'am. Yes, ma'am. My CFG file, ma'am. So we started testing, ma'am. Here you can see the batch file, which is known as this will detect the yellow with the batch size, ma'am. Then subdivisions. This will split into mini batches, ma'am. Batch are split into mini batch and subdivision, ma'am. There is a small manual allocation list, ma'am. So to test any video, we need to divide the batch. Batch should be divided subdivisions, ma'am. For example, for like that. Then when coming to training part, it will recognize the pixels constitute items involved near limitless points, ma'am. So here you can see channels, ma'am. I have given channels as 3 now, ma'am. It is OpenCV to display the resulting frame with detection around it as boundary limits, boundary boxes, ma'am. So it will show in 3 different boundary boxes like red, green, and white, ma'am. I have given that here. Then you can see here momentum and delay and angle. Angle is the image rotation angle which we are given, which we will give in while taking capturing images, ma'am. Then coming to saturation, exposure, and HUV, ma'am. These are used instead of RGB when used to describe the image, ma'am. So this will be used instead of RGB, ma'am. When coming to learning rate, it will be given as 0.1 in all the cases, ma'am. So what is burn in is number of batches to run the LR from 0 to 0.0.0. Next one is max batches, ma'am. It is nothing but a number of batches required to train the model, ma'am. Then coming to policy, ma'am. Like policy will be there. It will be taken from directly types of LR, ma'am. Like learning rate, ma'am. These steps and states are the size of our like output, ma'am. Output presentation, ma'am. Like boundary box will be getting, ma'am. Further, we use the scale and the steps, ma'am. Then coming to convolutional, ma'am. Actually, we use a CNN model to this, ma'am. This convolution. So when coming to batch normalization, it is the pre-processing step from previous layers, taken from previous layers, ma'am. Like before going to next layer, we can modify the current layer with the values which we needed, ma'am. Further, we use batch normalization. Then coming to filters. We filter each box, ma'am, based on their objective score. Like boxes having a less threshold energy will be ignored, ma'am. Like we should fix a threshold energy before, ma'am. And boxes having the minimum threshold energy will be taken as the consideration, and these filters are used to get rid of box with low scope, and this will select only one box when several boxes overlap with each other, ma'am, and it will delete the object, ma'am. So filters are used in this, ma'am. Then coming to stride, the network downsamples, ma'am. The network downsamples the image a factor called stride, ma'am. Like it will divide the image into different strides, ma'am. So we can name it as a stride of any layer is network is equal to the factor by which output of the layer is smaller than the stride, ma'am. This is called stride. Then here we have given activation as leaky, ma'am. like they have three type of networks in ma'am. So we use the network here, ma'am. So activation equal to leaky in the network, ma'am. By that, it will take the entire video which we have given, ma'am.
How do you change your streaming here?
Huh?
How do you change your input stream here? If I want to
So
change my
when you go
clippings,
into
how do I change
when you
it
go into
here?
it, ma'am, we have to take we have to record our video and present it here, ma'am.
Okay,
And
from
we should give
here?
our video name here like 1, 2. We can run directly from here, ma'am. Like I'm going to prompt. Just a minute, I'll show you. Oh, it will ask for video, ma'am. Video name Windows videos folder,
Okay.
ma'am. For example, if I give video 1 dot mp4, we'll get another video, ma'am. This is another video, ma'am.
Okay.
In the same way, if I give another one, okay, ma'am. Can I give another one?
Yes.
Okay, ma'am. I given video 2, ma'am.
Okay.
Oh,
So
you
what
can
is
see
the
this.
maximum size of the video it could support? Have you tested?
Ma'am, I have tested with 3 minutes of video, ma'am. Like that is my maximum video.
Okay. Okay, fine. Good.
Thank you, ma'am.
Next stream.
Yes, ma'am. Hello, ma'am. This is Mallikarjun.
Yes. Start presenting.
Ma'am. Ma'am, is my screen visible?
Yes, visible.
Yes, ma'am. This is project is brake level system. So this is a brief picture about how it works. So actually, this existed vehicle system with some
Your
embedded
voice is
sensors
breaking,
like
man.
gas,
Your voice is not
shock.
clear. It's breaking for me.
Okay, ma'am. Let me. Ma'am, now, ma'am.
Yes, clear. Proceed.
Hello. Yes, ma'am. And with other sensors like tilt sensor, gas sensor, and temperature sensors, ma'am. And existed system, we have only GPS and GSM modules where we can track the system. Um, so with this project, we can find where the accident occurs, and we can directly notify to the registered mobiles and emails, and also theft detection also, ma'am. So this is new system. In this new system, we have fire alert, gas alert, and theft protection. This is the block diagram. So for this we implement other sensors. So I will show you them. Ma'am, is my window visible?
Yes.
Yes, ma'am. So now I have embedded three sensors, but I have planned to implement the shock sensor, but it is not available in Tinkercad. So this is a temperature sensor, and it is a tilt sensor, and this is a gas detector. So whenever some gas, any type of gas is detected, it will notify or buzzer, and also for the temperature. So I have given 38, less than 38. So whenever it reaches more than 38 degrees, it will show the LCD, and it also alert. And for tilt, it is 0 or 1, ma'am. Whether it is when it is detected, it will fall detect, and it will message me about the code. If there is a yes, I will stop. It will keep on. Yes, ma'am. For the ESP, if there is a ESP module, we can with the thinker stick we can directly do it, ma'am. That's it, ma'am. Hello, ma'am.
Yes, can you explain the code completely now? Open the code alone. You change some message and send the
Hello,
message
ma'am.
now.
Hello, ma'am. Are you there? Hello.
Open the code and explain the code. Are you going to explain the code now? Malikarjuna, are you going to explain the code now?
Yes, ma'am.
Explain the code. You're the last member now. Explain the code, we will wind up.
Okay, ma'am. Ma'am, here we are importing. Actually, this is not working without ESP or any Wi-Fi module, ma'am. So liquid crystal for anything that happened with the sensors that is going to display on this LCD. So these are the
So
so
your code is
some
not working.
working, ma'am.
Mm. Change
I
the content of the code and show me the display.
okay, ma'am. So I will change this temperature, ma'am. This is so easy.
Yes.
Or so for Paul detect only two inputs, ma'am. Whether it is low or high, one and two. So this is a gas about the gas. So I told you about. So even very, I need to stop this machine. Even for let's say 50 degrees. Actually, I have explained about that ESP 8266 module, ma'am. You are not there.
Okay, Malikarjuna, you change some code and show me the output. I'm not asking you to concentrate on
Yes,
the
ma'am.
module which is not working.
Okay, ma'am. Before it was at the middle, ma'am. Now I have now I have moved so far from the middle, so you can see there is a difference, 50-degree difference, no? And also this gas, we can also change about the gas distance also. So these are the we can modify the time and delay of the buzzer. So instantly it will buzzer. So we just modify to 2000 milliseconds, which is 2 seconds after the gas. That's it, man.
That's all.
Yes, ma'am.
Okay. Okay, you join the live stream now. You just vote for any of your team members to get this thing. Okay. Okay, thank you so much. So we will be meeting on the next day on Monday with all your project demo completely. Thank you so much.
Thank you, ma'am.